Hello guys, in this tutorial we will cover NumPy basics. Okay, so NumPy is just one of those libraries that anyone in the data science, AI, and analytics space needs to be familiar with. Okay, so let's get into it. All right, so NumPy basics. So here is just a quick overview of what NumPy is. So NumPy is just a Python library that allows you to do a lot of scientific computation. Okay, so it's designed to work with what is called arrays. Okay, so all right, so that's just a brief summary, but let's go over this document. So NumPy is the foundational package for numerical computing in Python. Okay, so it provides what is called an ND array. So it's an n-dimensional array. And the best way or the simplest way to think about what is an n-dimensional array is think about of a data structure that allows you to store information in it, which in this case is going to be data. It could be numbers, it could be labels. And then once the data is stored in an array, then you can start analyzing the data, and then at that point you can do whatever you want with that data. Okay, so it provides the ND array, which is a fast and space efficient multi-dimensional array. Okay, and not only that, it has capabilities for vectorized computation, broadcasting, mathematical operations, and linear algebra. Okay, so again, an array is an optimal, or in some sense is an efficient data structure that allows you to not only store data but also perform operations on that data. Okay, all right, so let's start going over the foundations of NumPy. So then the first thing that you need to be familiar when it comes to NumPy is you need to learn how to create an array. Okay, and an array is going to be simply created as follows. So after you load the library, so import NumPy as NP, which is a very standard notation when it comes to loading a NumPy, then the command that you need to remember if you want to create an array is just array. It's just as simple as that. So what that creates is just a one-dimensional array with the values 1, 2, and 3. That's it. Okay, another important command when it comes to array is zeros. Okay, so this will create an array with zeros. Okay, so in this particular case, it's going to create an array, a two-dimensional arrays with 2 rows and 3 columns. So then this right here creates the following: 0, 0, 0, 0, 0, 0. Okay, and then another important command is arrange. So this just create a sequence of integers that start at 0. Okay, in this particular case, it creates an array as follows: so 0, 1, 2, 3, dot, 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 8, and 9. Okay, so keep in mind that everything in Python starts at 0. Okay, yeah, so then that's basically what arrange, the command arrange in NumPy creates. Okay, so then that's basically how you can create arrays in Python. It's very simple. And then here we have a table that summarizes other important functions that you may want to keep in mind. So array, that's just what we covered. Arrange is just similar to range but returns an array, zeros or ones. So then yeah, so then there is a function that is called np ones. So if you, for example, if you do 2,3 for np1s, that creates a two-dimensional arrays with 2 rows, 3 columns, and it will fill all the values with ones. Okay, so it will look something like this. Okay, and then empty, so then that's a command that creates an empty array, so meaning that without initializing the entries. Then we have I and or identity, so MPI. So for example, MPI2 does the following. So it creates this, a 2 by 2 dimensional array. So that's the identity matrix, right? So those are the standard commands that you need to be familiar with when it comes to arrays in NumPy. Then another important component here is the data types, okay? So as you are creating the arrays, you can specify what is the data type that you want to assign, okay? So in this particular case, because we have floating points, and what I mean by floating points is, think of, in this case, is 1.5, so that's a floating point, 2.3, 3.1. So we can specify the data type. In this case, we are using float 32. Okay, so, or maybe if you're creating an array called x, np array, and then if all of the value happens to be integers, like 1, 2, and 3, so then you can specify d type equals to np int 32. Okay, so when it comes to d types in arrays, so here this table summarizes some of the common options. So we have int32 or int64, so those are for integer types, and the meaning behind 32 and 64 has to do with 32 bits of memory that's going to be used, or 64, that's for 64 bits of memory. Same thing applies for floats, so we have 32 and 64. Another data type is bool, so that's for boolean, meaning that's true and false. Object, so that's for generical Python objects, so think about labels, right? For example, 1 in quotes, so that's an object. Yeah. All right, so those are the types, the data types that you may want to consider, including explicitly as you are creating your arrays. Okay. Then the next important concept, or the next important topic that you need to make sure that you're familiar with NumPy arrays is, arrays operation and indexing. Okay, and it's very simple and it's very easy to understand what's happening here, right? So then again, keep in mind that we are learning NumPy with the purpose of not only storing data, but also to do some manipulations to the data, because at the end of the day, if you're modeling a specific data set, so then the information is going to be stored in an array, and then you need to do some calculations on it. Okay, so then knowing how to do this type of operations and indexing is really crucial. Okay, so for example, this simple example, right, that creates a one-dimensional array with the integers 1, 2, and 3. And for some reason, let's say you want to multiply each of those values by 2. So this is what you perform, array asterisk 2. So then basically we'll multiply each element in the array called ARR by 2. So then this is the output. So this is just a very simple example. Okay, so you can multiply an array by a constant. You can add two arrays. Again, keeping in mind that they have to be on the same dimension. So meaning that they, talking about two arrays in one dimension. So if they have the same number of entries, so then the operation will work as expected. So this is what I mean by that. So if I have an NP array, for example, 1, 2, and 3, and then plus NP array 4, 5, and 6, right? So two arrays in one dimension with 3 entries. So then the result of this is going to be an NP array. So it will be 5, 7, and 9. And where these numbers are coming from, 5 is going to be just 1 plus 4, that's the 5 that you see here. And then 2 plus 5, that's the 7 that you see here. And then 3 plus 6, that's the 9 that you see there. Okay. So then that's just a very simple arithmetic operations when it comes to arrays. Another important component is making sure that we know, or that you know, how to do indexing and slicing of the array. So in this case, this very simple example is just creating an array with the values 0, 1, 2, 3, dot, 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 a and 9. Okay, and then basically 5 column a, so that creates a sequence that starts at 5, then 6 and 7. Okay, so it's selecting the 5th entry, the 6th entry, and the 7th entry of the array called ARR, and then we are explicitly changing the values to be 100 in those cases. Okay, so then basically here the result of this, it modifies the elements at indexes 5, 6, and 7. Okay, so this is the original one, and then after we perform this operation, this will be the result. It will be 0, 1, 2, 3. Now the 5th element is going to be 100, then 100, then 100, then 8 and 9. Okay, so that will be the result of this line right here. Okay, so again, these are just two simple examples that shows, you know, array operation and indexing in general. Another important component when it comes to array is Boolean index. So basically it has to do with having true and falses. So when it comes to using Boolean index in arrays, so if it's a true, so then that means that that particular element of the array is going to get selected. If it's false, so then that means no selection. Okay, so in this particular example, so then here we have an array with labels or objects. So we have Bob, Joe, Will, Bob, Will, Joe, and Joe. So it has 7 elements in it. And then here we're just creating a very simple, we're creating a 2-dimensional array. So this has 7 rows and 4 columns. Okay, we are populating those with numbers that come from a normal distribution. Okay, and then basically here what we're doing with names equals to Bob, so then that generates true and falses. So then this will generate the following. So it will generate true, it will then false, then false, then true, then false, then false, and false. Okay, where those values are coming from. So then basically this is the following. Okay, so then just as a friendly reminder that double equal pretty much in any programming language means check for equality, or the logical equality operator. Okay, so it's checking when names is equals to Bob. So if that is the case, it returns true. If that is not the case, it returns false. So then the first value that we see is true because the first element in the array called names is Bob, so then it returns true. The next one is false because the second value is Joe, and Joe is not equal to Bob. And then the next one is false because here we see Will. Then the next one is true because here we see Bob. And then false here, then false, false, false because we see Will, Joe, and Joe. Okay, now notice that the result of this expression, of this logical expression that we see there, is going to be used to index the array called data. Okay, so then basically this right here will do the following, because we see true here and then we see true here. So it will select the first row and the fourth row of the data, of the array called data. Okay, so when it comes to Boolean indexes, so when you see true, so then that means that the corresponding element to the true will get selected, and false is otherwise. Okay, so that's how you can perform also Boolean indexes with arrays. Then another component, or another important concept when it comes to arrays, is something that they call fancy indexing. indexing. So this allows indexing using arrays of integers. So it creates copies rather than views, okay? So in this particular case, so then first we are just manually creating an empty array, and then we're populating this array with the value called I, and I goes from 0 all the way to 7. So then basically what this does is the following. So then this is an A by 4, so then we have the following. So here we have 0, 0, 0, and 0, and then 1, 1, 1, 1, 2, 2, 2, 2, all the way up to 7, 7, 7, and 7. Okay, so this is the array. So it has 8 rows and it has 4 columns. Okay, so that's what these commands, these 3 lines of code, that's what they do. Okay, so again, and then here what fancy indexing is doing is just allows to indexing arrays using integers. So a very common thing that you will see, especially when you're working with arrays, is negative integers. So here we see the -1 and the -3. So basically, and this also applies to Python lists, okay? And then that will be the topic of another tutorial. But when you see negative integers for indexing purposes, so then that means that you are going backwards, meaning that the -1 means select the last row from that array, and the -3 means that selects the third last row of the array. So then going back to the array that we have here, so this is the RR. So then this command right here will select the following. So we will see 7, 7, 7, 7, and then the -3 will select 5, 5, 5, 5, because 5 is the bottom, the last third row. Okay. You can also select multiple elements. For example, this one right here, it creates the following array. So it's an A by 4. So then 1, 2, or excuse me, it starts with 0, 1, 2, 3, then 4, 5, 6, 7, until we see 31, 30, 29, 28. So it just creates an A by 4 array, an A by 4 two-dimensional array with the integers 0, 1, 2, 3, all the way to 32. Okay, and then here, let's say for some reason you are interested in the 1,0 element, the 5,3 element, and the 7,1 element. Now, before we talk about those, so let me mention something here. So if you have an array, right? So think about that you have squares in it, okay? So in this case, right, it's a 3 by 3. Let's keep things simple just for illustration purposes. So this will be referred as the 0, 0, 0, 1. This will be 0, 2 in terms of indexing, okay? And this will be 1, 0, 1, 1, and then this is 1, 2. This is 2, 0, 2, 1, 2, 2 in terms of indexing, okay? So if we want to select the elements 1, 0, now you know what that means, the element 5, 3, and 7, 1. So then again, 1, 0 refers, look at the first row and column 0. 5, 3 is look at the fifth row and column 3. And 7, 1 means look at row number 7 and column 1. So if you want to select those 3 specific values, so then you need to define it in this fashion. So then 1, 5, 3, so that's looking at the first row, the fifth row, and the seventh row. Well, everything in Python starts at 0. So then technically 1 is the second, and 5 is the 6th, and 7 is the 8th. Okay, but then you get the point. and then 0, 3, 1. So then that refers to the column indexes. Okay, and that will select those. Okay, so for 1, 0, so that will be that this value gets selected. So then yeah, this is 1, 0. 5, 3, well, you will have to look at that row. 7, 1, so that will be this one right here. Okay, so you can select multiple elements in that fashion by specifying what row and what column. Transposing, so this is another, well, this falls more on under linear algebra. So then transposing, basically what it is just flipping the rows and the columns. So then, for example, you have an array that has the following, right? Let's say it's 1, 2, 3, 4, 5, 6. And then if you apply the transpose, so then now you flip the columns with the rows. So then the result will be 1, 2, 3, and then 4, 5, 6. So then the first row becomes the first column and the second row becomes the second column. That's basically what it is, or that's basically what the transposing operation does. Okay, so again, this is more on linear algebra, and it's while the transpose of an array, or if you want to be more formal, the transpose of a matrix is a concept that is widely used in statistics and applied mathematics. Yeah. Then another useful thing, especially if you're working with arrays, so then is you need to keep in mind functions, right? So then not only, again, the array is being designed as an efficient way to store data, but also to perform operations with it. And there are already some functions in general, they have been developed to do array manipulation. So here are just some of the a very short list. There is more functions, but you will need to go to the NumPy website and go through all the documentation page, and you could see all of the different functions that they have there. And then here are some of the standard ones that, especially if you're working with data, these are the ones that you will use it often. So the absolute value, square root, square, exponential, the log, and the sine. So those are standard functions, okay? And then those are standard functions that applies element wise. So for example, you have an array that if you have your array, is the following: -1, 2.5, -2, and 4. And then you apply the NP ABS there. So the function, it applies element wise. Okay, so then the result of that will be an array that has the following. So it will be 1, 2.5, 2, and 4. So it applies the absolute value to each element in the array. Same thing for the square, the square root, the square, exponential, the log, and so on. Again, so if there is already a NumPy function that you can use to perform whatever operation you want to perform, it's highly recommended to use those functions on the NumPy arrays, because those functions, they were developed in an efficient manner to speed up the computational process. Okay, so yeah, so then here is a very simple example of creating an array and then applying the absolute value and then squaring each of the elements. So then this basically, first, what you see here between the parentheses, it performs the following. So it will be 1, 2, 3, and 4, and then the NP SQRT. Then you will see the following. So the square root of 1 is 1, then the square root of 2, then the square root of 3, and then 2, because the square root of 4 is 2. Okay, that will be the output that you see there. Yeah, so then these are standard functions that you can apply to one-dimensional arrays. And if you want to perform operations on two arrays, so then you may consider add. So that adds two arrays, subtract two arrays, multiply two arrays, divide, maximum, minimum, and mode. Okay, so those are standard arithmetic operations that you may want to consider if you're working with two arrays at the same time and you want to perform one of these operations. So then yeah, so those are already built and ready to be used from NumPy. And then here we have a very simple example. So we have two one-dimensional arrays, x and y, and NP maximum of x comma y. So then the reason why we see the output 4, 5, and 6 is basically is looking at the corresponding elements. So then the first element in both arrays is 1 and 4. And the maximum of those two is 4. That's the reason why we see the 4 here. And then it looks at the second element of those two arrays, which are 2 and 5. And the maximum of those is 5. And that's the reason why we see 5 here. And then next is 3 and 6. The maximum of those two is 6. And that's the reason why we see 6 here. Okay. So that's just a very simple example. This last section basically emphasizes what I mentioned a few seconds ago. So if you have your data stored as an array and then you want to perform one operation, you know that that operation involves some sort of functions or mathematical calculations. Those calculations are already developed as a NumPy function. Use that, okay? Because the whole process, the whole computational process is going to be faster and efficient. So then here is just an example that highlights that. So then here is just is using this particular array called X. It has 3 elements. So then it's performing the ABS. That's the absolute value function. That's for absolute value, and it's part of just your regular Python absolute value. So here is just performing or computing the absolute value of each element in that array, and then it's using math.squared. So math import math. So then that's another standard Python library that has a bunch of mathematical functions there. Yeah, so then here is just we are applying the absolute value to each element of X, and then we are taking the square root of those elements, of those results, okay? And we are using a for loop to do that. Yeah, so you can do that, and then I will show you in a couple of minutes. But what is more efficient is because you already have your data sitting as an array. So then here is a typo, it should be X, right? If you have your data already sitting as an array, and then there are the two functions that you want to perform, they also happen to be NumPy functions, you should use those. So NP ABS and then NP SQRT. I will show you that this right here is much faster than performing this right here. Okay, so at the beginning, again, you're not going to notice the difference because you're working with very, very small arrays. But then imagine that you're working with bigger data, with more and more rows or more and more columns in your array. So then at that point, you will start noticing the difference in terms of computing time. Okay, so this is just a list of some important topics or important concepts related to arrays. You know, I call it NumPy basics. Okay, there are more. So then I have a couple of I think one more or maybe two more tutorials that I have in mind for NumPy. But then for this one, I'm just gonna keep I just wanna cover these topics. All right, so then now let's jump into NumPy basics in action. So then we're gonna start writing some code and playing with NumPy. So let's get into it. All right, so then here I have my notebook. So then the very first thing that that you want to do if you want to start working with NumPy and NumPy array, so first we need to load it. So again, I'm making the assumption that NumPy is already being installed. So import NumPy as np. Okay, so let's start by defining a very simple array. So let's call it x equals to np array. So let's use 1, 2, 3, 4, and 5. Okay, and let's print it. So that's my array. It has 5 values in it, and in general, right? So in this case, I don't need to use this command, but then if you want to find out the dimension of your array, so you do just that shape, and it will tell you the dimension. So there is a one. This is a one-dimensional array with 5 entries in it. But if you create a two-dimensional array or a higher dimensional array, so then it will show you those values. So then, for example, if I have y is equal to that, right, and then let's print y. Oops. Let's bring y. So now it's a two-dimensional array. Now when I do y dot shape, now it says 2, 3 because it has 2 rows and 3 columns. Okay. All right. Let's go back to do some operations on x. So for example, if I want to multiply x by 3, so I just do 3 times x, and that will multiply every single value of x by 3. Okay. And if I want to do a square, right, for example, I could do something like this, right? So then that's the double asterisk, so that's exponentiation. Or if I want to do np square applied to x, oops, so I also get the same result. Okay. Let's see what else. So going back to the examples that I have. Oh, so if I want to create an array with zeros, so np zeros, so 2, 3. So as I show you on the node, so it creates an array, a two-dimensional array with 2 rows and 3 columns. Now, one thing that I want to emphasize here is you see 0 dot. So basically here, if I do d type, so it's treating each element as a float. Okay. And if you want to change that, because these are your zeros and you don't need them to be float values, again, you can also use the dtype command or the dtype argument to set that to be integers. So now I don't see the dots anymore. And yeah, so that's how you can specify the dtype. Okay, what other example I had? Okay, yes, the last thing that I want to cover is, especially when it comes to performing functions, right? The last example that I want to highlight here is if your operation relies on mathematical function, there is a high chance that that function has been implemented in NumPy already. So if that is the case, rely on NumPy function. So then that will make the code run faster in some sense. Okay. All right. So let me quickly show you that example. Let's replicate that. So let's use the same X that we have. Let's say we're interested on taking the absolute value of each element, and then we're going to square that. Okay, so let's do that. So let's say result is equal to let's do this math So math that square x square, then absolute value of x for x in x. Okay, so we need to import math. And then let's use the time command just to time how long it takes. So let's run this. Okay, so it took 16.9 milliseconds. Now let's do the same only using NumPy commands. So it will be this, right? So we want to apply the absolute value to x and then the square root to that. So let's run this. So it took only 7.29 milliseconds. So pretty much it's just 2.2 times faster. So yeah, let's calculate that. 16.9 divided by 7.29. Yeah, 2.3 times faster. Okay, so again, in this case, you don't appreciate much of that. You don't appreciate that because we're dealing with such a small array. But the more data that you have in that array, then you will notice the difference. Okay, so the moral of the story is if you have your data sitting in an array and you want to perform some sort of like a mathematical calculation, there is a high chance that that calculation is already being implemented in the NumPy library. If that is the case, use that implementation because it will speed up the computational time. Okay. All right, so that's all I have for in this tutorial. So then this is just the first of a few NumPy basics tutorials. Okay. All right. See you on the next one.